In this section, we'll be talking about isosceles triangles. And if you remember back in chapter 1, we defined isosceles triangles, although it was probably something you already knew. And it was defined as a triangle with at least two congruent sides. So that might have been a little bit different for you. And basically that means that if it's equilateral, it'll have the properties that isosceles triangles do as well. But for any investigations that we'll do, we'll just assume it has just two congruent sides so that we can make sure it works for all. So the biggest thing is to remember the vocab here, and notice the vertex angle is the angle at the top between, it's not in the top always, between those two legs. And the base angles are the two angles that aren't the vertex angle. But remember, it can be turned as well. So you could have base angles up here at the top, and your vertex angle is still going to be between those two congruent angles. So it doesn't matter how the triangle is turned, and in geometry, the base does not have to be on the bottom. So it could be sitting in any way. There's still going to be base angles if they're not the vertex angles. Find your two congruent sides, and there's going to be your vertex angle at all times. So these are just some great pictures of isosceles triangles in buildings. I'm sure you've seen plenty of those. You can just go just about anywhere and you'll see some isosceles triangles in architecture. So you can look at your book or just look around you and you'll see those. On your paper, go ahead and use your ruler as a straight edge and as a measuring tool to draw an isosceles triangle. You could be pretty creative and construct an isosceles triangle as well using your compass. So go ahead and draw an isosceles triangle, pause the video, and take care of that. All right, you should have your isosceles triangle drawn. You could easily use the ruler just to measure the sides to make sure they're the same measure as you're drawing it. A really easy way, I think, is to use your compass and just measure off congruent sides. You could have just made a little arc and drawn them. And once you have your isosceles triangle drawn, take your protractor and measure the base angles of the isosceles triangle. So for mine, here's my two congruent sides, and here's my vertex angle. So these two must be my base angles, so I'm going to measure those. So pause the video and measure your two base angles. All right, you should have discovered that your base angles are congruent. Remember, any measure that we make with a tool like a protractor or ruler won't be perfect. Looks like both of mine are 75. Yours shouldn't be that, but they should be both the same. So just line up that protractor and double check that. So with all of our different ones, and you could even draw some more just to make sure, but hopefully you think about it and its symmetrical qualities, that line of symmetry down the middle, and you should believe that. So if a triangle is isosceles, then the base angles are congruent. So we can use that now when we are trying to figure out problems. Now we need to write the converse of the isosceles triangle conjecture. We know the converse is when you switch the hypothesis and conclusion. So you'll still write if then, but you'll switch the hypothesis and conclusion. Sometimes you have to change things a little bit. So go ahead and write down what you think is the converse of the isosceles triangle conjecture. So hopefully you've tried that and you've got yours written. This one's a little different because the converse would originally be something like if the base angles of a triangle are congruent, then it's isosceles. So you don't even have to use the word base since you wouldn't know they were base angles when you first drew it. So maybe if two angles of a triangle are congruent, then the triangle is isosceles. So that's the converse. We don't know if that's true or not. So let's investigate that. Let's use your compass and your straight edge. Try not to use that protractor. You might want to try the protractor on additional drawings that you make. But let's first use the compass and the straight edge to draw a triangle, construct a triangle with two congruent angles. So it's a nice practice of our copying angles construction. So I'll do this one with you since this is a short video anyway. So I'm going to draw an angle, grab my straight edge here. I'll draw an angle of any size And I might have to come back and extend that ray. I don't know right now. I want to copy this angle down here. So the first thing I'll do is I will make an arc. This is the copy angle construction. So I'm going to make an arc of any size I want, but I want to keep that opening, so I'm going to try not to bump that. I'm going to bring my point down and put it to what will be the vertex, to the very end of that. If you don't go to the very end of your segment, make a point so you can tell where you are at. I'm going to make an arc that is congruent to this arc. So I had to make sure those two were congruent. And my last step is just to measure the distance between those 2 points of intersection. So there's one with my pen down here, and I'm going to have to do some adjusting to get the other one, and you'll have to do the same. So I measured that distance between the points of intersection, and I'll go down here and mark that off. I'll put my pen on the point of intersection, and I'll make an arc. My last step is to just connect the end point, which was my vertex, with the point of intersection. So I'll use my straight edge tool to do so. I'm going to have to extend this line a bit. And you can use your protractor to measure to see how that turned out. I think that's about 56. Oops. Looks like about 54. I need to adjust this a little bit. Yeah, this needed to be turned just a teeny bit. Oops. So they're close. Looks like maybe a degree off. We're trying to decide if the conclusion is true. So we made the two angles congruent the best we could, and we're trying to decide if the triangle is isosceles. So I think an easy way, easier than using my ruler, would just be to measure with my compass. Don't forget you can measure with those. Then you don't have to worry about even remembering that measurement. You just hold that compass open to that point. So there's a measurement of that side, and I'm going to compare it with the measurement of the other side. I don't really have to make an arc, I just have to measure those. Looks like that's pretty good since my compass, something happened with my measurement here. I'm going to double check my angles, and you can do the same thing with yours. Oh, I can see the problem. Somehow my compass didn't work very well, or I didn't work very well with my compass. So that makes a big difference if I take my segment now and move it so it goes through that point and my vertex. I wonder if my two angles and my two sides opposite them will be congruent as well. So do the same thing with yours, adjust measurements if needed. There's the one side as accurate as I can get it. And see if that's a little bit closer this time. Yep, it's pretty good. I also checked my angles to see how I did that first time. I should have changed those right away since it was, I guess a full degree off is quite a bit. There we go. About 54, and I'll have to turn it down here a bit too. So that's a little bit better. Looks like they're both 54. So the whole goal of that is if the base angles are congruent, then the sides are congruent. Notice where those sides are as well. So if these two base angles or two angles of a triangle are congruent, then the sides opposite them are congruent. And then that would force it to be an isosceles triangle. So we just determined that if a triangle has two congruent angles, then the triangle is isosceles.